Yeah, welcome back to my class. Today we want to look at queue mechanism. Now, this is also a concept to show you how multiple thread can process items on a queue concurrently. Now, let's take the story of Nehemiah building the wall, for example, in the scripture. But I'm not going to use that. But that is a clear story of queue mechanism. Now, in a simple manner, I'm just going to show you this using the concept of the conveyor belt at the airport. You know, the conveyor belt, you have the conveyor belt, right, that is used to bring the load from the plane to the passengers. So you have somebody on this other side that is putting those loads on the conveyor belt. And then you have people at the other side that are moving the load off the conveyor belt. So let's just assume that we have 5 boxes that we are going to put on this belt. And then we have 3 staff at the other side who are going to what? Take these boxes off the belt. Let's write a program to demonstrate that. So the first thing that we'll do is that import trading, import trading. Then I'm also going to import the queue module, and then I'm going to import time because I will need to simulate for a while. So I'm also going to import time. Now, I'm now going to create that task, which is that task of moving those items off the conveyor belt for processing, as in those boxes. We're just going to move them off. So I'll call it is a method. I'll say define worker. I'll just name it worker, right? Now it's expecting 2 parameters. And what would they be? The first one is name, which is what? The name of the thread. And then the second one will be what? The queue, right? So that is what I have. Now, what do I expect it to do? Because I'm going to have 5 boxes on that conveyor belt, and then these 3 thread, which are the 3 staff at the other side, will have to be removing them one by one. But they will do it concurrently. So the first guy will go for the first box, the second guy will go for the second box, the third guy will go for the third box. Then the first guy will go for the fourth box because there are only 3 of them. So the second guy will go for the fifth box. So to achieve that, I need a loop. Now I'm going to use a while loop. While true, I'll tell you why I'm doing this. While true. Now this is an infinite loop. It means that these workers will have to be checking the conveyor belt to be sure that there are no load remaining. So if there is no load, you will go and check. If there is no load, you will just wait. And then later check again. There is load, you will remove it. So because I'm using this while loop, which is what? An infinite loop, meaning these 3 stuff are never going to close. But for me to end it, if I want them to close, it means there must be an external instruction telling them there is no more boxes coming again. So you can close and go home. Right? So I will get to that point. But that is what this is. Until they get that external signal, they have to keep checking. So while true, go in and do what? Now create data. So I'm creating a variable, and then I'm assigning queue.get. Now this is a method inside this queue class that is going to take those items from the conveyor belt, right, for processing. So I'm creating a temporary variable where you take the box and you put it in. Then once this is done, I will now test this data because I need to give them instruction to stop, that there is no more item on the queue again. So I will say if data is none, right, break. So this is how I am going to end the job for the day for all the thread. So the instruction that I will give to them is that anytime you now see on the conveyor belt none, each of you see none, that means there's no more item coming. So you can close and go home. That is the instruction. That is what this line is for. If data is none, break. Else, I'm not using else. On this same line, I will say print. So the task is, I'll call my format string. Then I will say name, right? Processing. Processing data. So I'm assuming this is the task that I want it to do. So as long as the data is not none, meaning there's an item, so thread 1 will carry the item, right? Then time dot sleep. So I'm using this to simulate the time it takes for them to do that job. So as long as the data is not none, it means it is an item. So thread 1 will remove it. Then thread 2 will remove, thread 3 will remove. Now, thread 1 will remove. This is simulating the period it takes in removing to process the data. So sleep and then print out q dot task done, task underscore done. Now, this is also a method in this queue. It's also a method in the queue class. So this method is simply saying that that thread has finished that task. So what that means is that there is a counter that is checking how many boxes were put on the conveyor belt and how many has been removed. So if we had 5 boxes on the conveyor belt, the first person remove, that means the remaining 4. It will check. Second person remove, that means it's remaining 3. The third person remove, that means it's remaining 2. So the first person will have to come back and remove the fourth one. Then the fifth guy will come back and remove the fifth one. So this is checking to ensure that the task is done completely. So now this is the task that I want you to perform, right? So the next thing is that I'm going to create the queue, which is the conveyor belt, and then I'm going to load those items on it. So what I will do is I'll call it work queue. Work queue. Right? This is the queue. And to create this, my object, which is the conveyor belt, right? I'm going to say queue dot queue. So this is a method in the class. So I'm calling that constructor to create my object. So I've created my conveyor belt. Now I'm going to bring the items, which are what? 5 items. So I will put them here. Items. They are going to be in a list. So 1, 2, 3, 4, 5. So it's a list. These are the items. Now, I now need to load these items on this my queue. So how do I do that? I have to come here and I will say for item in items, right? For item in items, go in and do this work queue. Work queue dot put item, right? So I'm using this for item in items. You can see this one is item. It's not carrying, it's not plural. Why these items is plural? So this items is this variable. So go into this variable, load them one by one. So the first one will come into this item. This put is a method in the list. So that is what I'm using to input the item inside this queue. So I take the first one and I put, so I'm going to load these 5 inside the queue. I have done that. Now I'm going to create my thread, meaning I'm going to create the 3 staffs at the other end, who will now be offloading those boxes that are on the conveyor belt. So you will not be able to sit down. So I have to come here. What I want to write here now should be under this place. So I will have this. Now I'm going to create my threads. So I'm also going to create a list to hold my threads because they are at the other side. I will create an empty list. Now this is the list that I've created. Now I'm going to create my thread and then populate them into this list. So I will come here and I will say T. I'll use the for loop. I'll say for I in range. This range 3. So I'm creating just 3 items. For I in range 3. So this range 3 is 0, 1, 2. Right? That's what I have. So the first one, which is 0, will be loaded into this place. I'll now say T equals to threading dot thread. I'm calling the thread constructor to create the thread object, threading dot thread. Then what do I want the thread that I will create to do? I want it to perform this task. So the target, right, equals to what? Worker, which is that function. All right, then comma. Now it's expecting 2 arguments, but this place is not enough, so I'm going to come down. So what should be here is what I want to write here. It's expecting 2 arguments. So the first one will be what? Ask, that is the argument. Then this, so format string, thread, so that is the thread name. So I will have this and then I will do this. Because of this I, which is 0, so I will say I plus 1, then I'll use my curly bracket. I will close this. So then the second one is Q. So this work Q is what I'm going to supply there. Work Q. Right? Then I'll close this, then I'll close this. So these are the 2 parameters that I'm going to supply. Then the next thing I'll do here, everything I'm writing here now should also be the same line, right? Inside this for the same line. But because of this space, that's why I'm doing that here. So please understand. This one should be here. So T dot, I'm going to start the thread. Start. So I'm calling the start method to start the thread, which are those 3 threads that I've created. So I've given them the instruction to start working. Then I am also going to say thread.append, which means I'm copying this thread into this place. So to populate that, threads.append, append T. So this line is simply populating all the threads that I've created into this thread list. So now I've created my thread and I've started the thread and I've populated the thread list, right? So this is another part that I've completed. I created the thread, the task here. Then I created the queue, populating my queue with 5 items. Then in this place, I created the thread and I'm instructing the thread to perform this task, supplying with this parameter, which is thread 1, and then 1. So thread 1 will go here, 1 will go here. Once that is done, I want each thread, the main thread, to wait for each thread to complete their task. I will now say work queue dot join. That is this work queue. So every time a thread will perform the task, This instruction is to prevent the main thread from continuing with further activities until all the threads perform their task. Now, don't forget that at this point, we created an infinite loop. So even if the thread finishes offloading these 5 items, they will still keep checking to see if more items are coming. So I need to instruct them to go after they finish this by sending an external signal. So let me do this. Right? This place will not be enough. It should be on this same line. But because this place will not be enough, I want to write a loop. So let me write it here. So I will say for now, because I'm not going to use this variable inside my loop, that's why I'm using underscore. For this in threads, right? I will say work queue dot put none. Now, this is an external instruction. This is the signal that I'm giving to this my thread. So I'm telling them each thread. So the first thread inside this thread, which is this one, all the threads were stored here. So I'm telling the first thread that anytime you see in the queue, I am putting none. Anytime you see none in the queue, just go ahead and break. So when this none is supplied to this place, right? It comes in, it check data queue.get. So it's taking from that queue and putting it in data. Here it will now check if data is none, break. So this is the way I'm instructing it to do that break. So I am calling the queue and I'm putting none on the queue. So I'm telling each thread, anytime you see none, just go ahead and break, meaning leave. There's no point waiting anymore. So that is the instruction there. This instruction was for the main thread to wait for all of them to perform their task. Thread one will perform the task. Because there are just 3 threads, thread one will perform the task twice. Thread two will perform the task twice, right? And then after that, this one will make them stop working. Then the last one will be the final instruction that will be given for all the threads to return before the final thread will now close for the day. So that instruction will now be, the final instruction will be for T in threads, right? Go in and then T dot join. So this one will be instructing the main thread to wait for all the threads to return before the main thread will now do print exiting, right? So because of no space, I will have just written exiting main thread. So this is the final instruction. So this instruction here, this one is for you to wait for all the threads to perform their task. So 2 threads will perform the task twice because there are 3 and we have 5 boxes. So the first thread will do the first one, second thread will do the second one, like that. Now, once they are done, this instruction will be for them to stop because none is now supplied to the conveyor and each of them will see that none. And the instruction here is that once they see none, they should break. They should close for the day. So when they return back, the main thread will see all of them. Then the main thread will know that they've all done their task and we can now lock the office. So exiting. So the main thread will now print this exiting. It is the main thread that printed this. So concurrently, you have used 2 threads to do a task on the conveyor belt. That's what I want to show you in this class. So let's go to the PyCharm and let me demonstrate this for you to see the output. Okay, so this is our PyCharm. This is the script, like as we've been doing. So I've written the script already. So this is importing threading. Now, this is exactly what I told you. So now I have brought you away from the class realm. I am now in the physical realm where I now want you to see practically the manifestation of what I taught you in the classroom. All right. So this is import trading, import queue, import time. Now this is the task that we created. So this is the while true data, everything that I showed you on the board. Now this is the thread queue creation, and then populating the queue with 5 items. And then here we are creating our thread, and we are starting the thread. Then we are appending by copying this and putting it here. Now we have this telling you to wait block until all tasks are done. Then stop workers by adding none to the queue, which is what? Telling the workers to go home. And then waiting for everybody to return. That means all the workers have gone out. Then you can now exit the program. So let me run this for you to see what the output will be. So I click on this, you see the output here. See? Now you can see trading, processing one. So you can see, look at what it printed out. This is what I wanted to print out, as you can see. Thread 1, processing 1. Thread 2, processing 2. Thread 3, processing 3. Thread 2, processing 4. You can see. Thread 1, processing 5. So it means based on the way the operating system assigned the thread, the synchronization, thread 2 finished and then had finished quickly and processed the 4th item, while thread 1 processed the 5th item. So you can see that it did. Now, if you run it again, it might not come out this way. Now, let's execute it again. Now, see, thread 1 process 1, thread 2 process 2, thread 3 process 3. Now, thread 2 process 4, and thread 1 process 5. You can see that thread 2 actually finished and then went ahead to process 4 before thread 1 could now process 5. Thread 3 did not process anything again the second time. Then it will now exit the main thread. So that is it. That is what I want to show you in this class. Don't forget to like, and don't also forget to share this video. So till we see in the next class. Bye-bye.